Oh, I gotta get rid of some of this stuff. Sorry. Yeah. No, we need all. No, we don't need all that. Oop. Sorry, jump. Okay. So what we're gonna do is look at. Well, let's first talk, I think, about the organization of what you're seeing here, and then we're gonna break it down into more digestible chunks. Okay. So we've created a slider right here that moves the planet around the sun. So what you're seeing is that if this is the equator, right, the northern hemisphere is where we all are right now. The northern hemisphere in this position is leaning away from the sun. Okay, the North Pole, let me go into the side view here actually. So the North Pole is actually so far tilted that, actually I should explain one other thing first for you. So right now, this is an inaccurate diagram because the sun is so big and so close to the Earth that one might assume if you draw a tangent from the sun down to the North Pole that you're getting light. But the sun's light doesn't work that way because of the vastness of our solar system. The light that we get is actually assumed to be straight. Comes in and it hits the planet at a straight ray. And let me draw a quick diagram up here. It's a straight ray if you're exactly in line with the sun. It's considered a straight ray if you're up in like Alaska and that's coming in. Because our planet is so small and the sun is so big, the rays that are coming from the sun, which are radial, are assumed to be straight because we're really, really tiny. Okay, they don't spread enough when they reach us. Nor do the sun's rays actually come from up here and come in. To a degree they do, but it's irrelevant because once it hits our planet, it pretty much all disperses, so it's assumed to be straight. Okay? All right, so we're going to look at sort of shade and shadow studies a little bit, but the North Pole is so tilted that at this time of year, it actually gets no sun for the entirety of the day, right? All 24 hours as it's spinning around this axis of rotation, there's no sun. Let's rotate it around a little bit to about 91, 92 days, which is a quarter of the way through the year. And let's look at it now. Where are we? Okay, so here, the northern hemisphere and the southern hemisphere are getting approximately the same amount of sun, right? So they are, the equator is essentially the closest point to the sun in this location. Yes. Now, really, the Earth is on an elliptical path, so it's not exactly a 90-degree thing. Well, if you want to get into it, we can get into it. But for the purposes of studying this kind of analysis, this is enough information for us. So we rotated a little bit more to about 180-something days. And now we're on the other side of the planet. And now the northern hemisphere is leaning in closer. So that's our summer. And it's the southern hemisphere's winter because the South Pole now in this case is getting no sun for the entire day. Is that clear at this point? Okay. So for those of you who are in design, I'm sure you've been really beating a dead horse on this already. So I do apologize to those of you who are. For those of you who are not, it may have been a while since you've heard this, but it's good to be refreshed. Okay, so this is basically what we're going to be predicating a lot of our studies this semester on. It has to do with, and I mentioned vectors specifically today because vectors are going to drive a lot of what we're doing, right? The information that comes from the sun study is actually a mathematical relationship that we've just constructed. So if it's a sphere, and let me grab the sphere that we're working with here. This one. Okay, so we have a sphere here that is, oh, you know what? We're going to have to rotate that into plane first. Darn, I didn't want to do that. I guess we could. Anyway, we're going to have to take a quick diversion and actually rotate the planet into orientation, but I want to show you why first. So this is more Grasshopper, less solar system stuff. Let's go back into Grasshopper here. So we're going to talk quickly about subdividing the planet. For those of you who are in design, you've already talked about the latitude and longitude of the planet, right? If we're going to be calculating information based on the latitude and longitude, really all that is a subdivision of points along the planet's surface, right? So we have a really cool tool, I think, under Math and Domain. Divide domain squared allows us to take pretty much any surface and break it down into smaller bits, right? Panels, essentially. So we can divide domain squared like that. We plug G in to the I. Okay, the I is creating a domain. This is a new term. I promise you we will get into it more, but I don't think we really have enough time to get into it in full effect tonight. So I'm going to leave that at, basically it's a range of either space or information, length, distance, magnitude, that kind of stuff. So it creates boundaries or proportional relationships. So we plug in divide, which is under Math and Domain. Divide domain squared. Okay. And then we go to under Surface and Utility. This one that's called isotrim. Okay, so notice how the symbol for domain right there looks kind of like the symbol for isotrim. That's because isotrim is going to work off of ranges of information as well. In this case, it's a range of a surface. So the input values, and this is under Surface and Utility again. The input values for this are the base surface to trim or subdivide, and a domain to subdivide with. Okay, so the geometry here is an untrimmed surface for the planet. And then the domain is the segments that have been subdivided by your divide domain squared, which is that. So then as we zoom in on our Earth, what you're going to notice, oh, you can't really see it on screen there, huh? Well, there you go. You can see that. Okay, I'm going to pause for a second because I hear some chatter. So I'll pause for a second and get us to this point. So I do want to point out to you guys real quick that isotrim has this little parenthesis or bracket here that shows subsurf, right? Kind of sounds like subdivide surface or something like that. It technically does subdivide the surface, but for some reason they call it isotrim. I can't stand that they do that. But I'm going to give you a hint right off the bat that this is one of the first pairs of components that we're going to use a lot. And I mean a lot, a lot. So when you have isotrim, we're going to be using that in conjunction with divide domain quite a bit. Okay, so those two are, you're going to see that a lot. And just remember that it's sort of this triangular configuration like that. Okay, so let's talk real quick about the sphere itself. So now you see it's starting to look a little bit like our globe, right? You usually see the equator is cut through it, the latitude and longitude lines are all there. It's pretty much just a subdivision of the Earth's surface. So we can grab those points and use that as a means of understanding where certain points on the planet are at certain points of the year. But in order to do that properly, we have to then tilt the Earth as well. Okay, so the easy way of doing that, at least for me, is to create another connection. Okay, so that connection for me is going to be what I call the Z-Earth. All right, so we have an Earth origin, a new Earth center, and you guys could do this or not do it. It's up to you at this point because I've given you the tip. You could take it if you don't. That's fine. I'm going to call this one Z-Earth. Oh, sorry, yeah. Yeah, it's under params and under geometry. It's actually, I'm using surface. That's important to note. So I mentioned this on Tuesday. There is no param for sphere because a sphere is just a surface. Yeah, so oh, you can't see my wire display selection. I'm going to make that hidden. And here's the key. I can take this and I can move it down to a rotator. And so this rotation actually did revolve the plane in its origin point. So technically, I could take my Z-Earth and I could plug it into G. I could join it, well, I could add it into G and it would do it. However, in this particular case, I'm trying to be more controlled about which information is being rotated using which ideas. So I'm going to do it again, except I'm not going to pair it up with this plane rotation. So all I need to copy exactly the same rotation is to take this, copy it, move it down, and at that point I can just replace the geometry. Like that. Yeah. So, yeah, I subdivided it in its origin. So what I would suggest at this point, guys, is to turn a few of these off, right? Because you've got too much geometry going on here. So you're definitely going to have to turn off your Z-Earth. Those are going to get in the way. So this Z-Earth, those turn off. You're also going to have to turn off your original subdivide surface. This one. So as a result, let me just finish up this thought and then I'll help you guys troubleshoot. As a result, now your planet actually tilts in the same orientation as the angle of declination. I'll help you guys troubleshoot here right now.